So here in this session, we'll be looking at the implementation of linear regression with Python using Jupyter notebooks and the library Scikit-learn. Okay, so the data set or the case study that we are taking over here is predicting the how prices of houses in the regions of USA. Okay, it's a very popular data set. It's available on Kaggle. It's an open competition. So it has the house prices of multiple houses and some of the features. Hello, am I audible? Is there a
So
problem?
no, no, my video was stuck. Can you repeat again what you said?
Okay, okay. So this is the case study here is related to predicting the house prices in different regions of USA. So it's a data set. It's a problem uploaded there on the platform Kaggle, which is a data science platform, right? So here we have multiple, we have collected data from multiple houses based on certain features. Okay, if it's a 2 bhk or a 3 bhk, or in suppose New York, then what is the price, and if it is in Ohio, then what is the price based on the phk and all that, right? So the data contains the following columns. So we have data collected in the forms of rows and columns. So my columns are the different features in which on which a house price may depend upon, like average area income, average area house age. Okay, so what is the age of the house mainly, and average area number of rooms. Okay, so just ignore this area. It's number of, how many number of rooms, number of bedrooms, what is the what is the population of that area, right? So in the house prices in Bangalore are going to be high as compared to the outskirts of Bangalore, right? And uh, price is what is the price of the house, and address is what is the address of the house. So we see that this is the price column in which we are interested in. So in our case want to predict the price based on all these parameters. Okay, so our y is going to be price, and our x vector, or x1, x2, x3, if there are multiple features, are they going to be these features like income, house age, how old is the house, what are the number of rooms in the house. Okay, so let's start with exploring our data. So data has already been downloaded from the Kaggle website, and it's the provided to you as a CSV file. You can download it from the Kaggle website also, right? So let's start with setting up our environment for doing some data analysis. So we'll import pandas, we'll import numpy. We want to plot our data. We'll import matplotlib.pyplot as plt, and we will also import seaborn, right? And I want to see my outputs in the just the output cell. So this thing we have to do just in Jupyter notebooks to see the plot in the next to the line, next to the code cell, right? So I'm creating a variable called USA variable, and I'm reading the CSV file using the pandas.read CSV method. And this is, I'm providing the file name. So all the data which is there in the CSV file is now being loaded into this variable USA housing. And this USA housing variable is going to be a pandas data frame. So I can use USA housing dot head to see the first 5 rows of my data. So this is how my data looks like. Okay, so these are the different columns. So maybe like it's around area income is around 80,000, and the average house age of that particular area is around 5 to 6 years, 5 years, or 5.5 years. Average number of rooms is 7. It is coming in point decimals. That's because it's an average. So average number of bedroom 4.9. You can take it as 4 or 3. What is the population of that area? It's around 23,000. Okay, so they are like, see, there are 23,000 people, and they're earning around 80,000 each on an average. So it's pretty much they're living a well life there. And next, we want just to see the descriptions of each of the column. I will use this method called pandas.info, dataframe.info. So USA.housing info. I see all the columns. So there are 5,000 entries. That means there are 5,000 rows of data. The indexes are from 0 to 499 because indexes start from 0, and there are data columns. Total 7 columns are there. In all the columns, there are no non-null, right? 5,000 non-null. That means out of the 5,000 entries, this column has not, and there are 0 nulls. So all the data are completely filled. So it's good only. Otherwise, we have to perform some kind of data cleaning and processing. But now it's fine. So let's go ahead. Right. Now let's describe the each of the columns. How do they look like, just to get an idea? So count is the number of occurrences, or it will be same. Then mean. So what is the mean of this particular column? So mean income in all the 5,000 rows is 68,000. Right. Mean age of house is what, around 6 years. Right. Then uh, mean number of rooms is around seven, or you can say six. Okay, and this is number of bedroom is four, two. So also, I what can I get? What I get is most of the houses are big. They have four bedrooms. They are six rooms already, and they are just 6 years old. So they are pretty much new houses only. So the data is so what can I get from this data is that, so my 5,000 data rows are coming from a recent 5 to 6 years only. So if I want to study, so I have to keep in mind that I am, so this does not represent the actual or the exact situation in US area. If we, I was, so suppose there are multiple houses who are 10 years old and they are selling at the half the price of it, right? So I have to keep this in mind, right? So this is so my data is what, some kind fairly new. We may find, because it's a mean, we may find some houses older than this also. And then what is the standard deviation? Right, so standard deviation is, should be close to one. Yeah, it's all close to one. That means it is no, it's kind of normally distributed. So there are a lot of values for very close to the mean, and they are gradually then going away from the mean. Right, very smaller values as we go far from the mean. No abrupt things like, so there are two, not there are no two means. Okay. Next is the, what is the minimum value? So minimum average income is $17,000, and the maximum value is okay, 1 lakh 7,000. Okay, we should use million, around 1 million. Right. Next is this is a 25. If I divide my data, if I sort these values, then the first 25% people earn this much. The almost half of the population earns this much, and rest more than up to 75% of the population earns this much. This is a quartile, right? So if you sort this column by in the increasing order of the area income, then at around one-fourth from top, you will find this much of value. Around midway or the half of the population is like earning this much, below this much. 75% of the population is earning below this much, and maximum is this much, right? So these are the top 25%, top 25 percentile. Okay, now let's just to get the names of all the columns, I can do USA housing or the data frame dot columns. Right, so I'm just trying to revise, give you a revision of pandas where you can just go back quickly and use it here, right? So I want to see what the columns are there. Okay, so I can use like this. Then we are doing EDA. EDA is the full form is exploratory data analysis. I'll try to plot different columns of my data and try to see if I can get some insights. So is there any relationship that I can actually model it? Sometimes, so we cannot put our linear regression or any machine learning anywhere. We first try to have some hint, or we try to had some pointer. Okay, because of this distribution is looking like this, so maybe they have some relationship, right? So I'll do a pair plot. SNS pair plot will plot all the columns. I will pass my data frame as cbond dot pair plot, pass this column, right? So when I plot all the integer columns with each other, I get a plot like this. It's very huge. It's not fitting on the screen, but let me zoom out. Okay, this is the max we can do. Okay, correct. Maybe right. So I have all the columns plotted with all the other columns. So the diagonal is histogram because it is average income with average income, average house age with average house age. So with it is with itself. So it does not, you can doesn't mean anything to put plot in two dimensions. Okay, and for other columns, so just forget the columns. I can direct just by looking at this plots, I can see that for all these things there are no relationship because it's kind of a circular. It's spread out in all the directions. There is no straight line, so you can actually make any plot and it will explain my data, right? So we can say that there is no specific relationship here, right? But I can see some relationship over this plot, top right. So it's kind of tilted towards one thing. It is not exactly a solid circle, but I can see this distribution here also. This kind of a tilt is there, and here also there is a tilt. So I see that the number of rooms, house age, and area income are kind of having some kind of relationship with the price, and it is kind of going increasing as we go towards the right. That means the price is increasing as I go up in number of rooms, as I go up in house age, as I go up in uh, average area income, right? So if the people are earning more and they are looking for higher number of rooms in their house, then the price is going to be more. This is what I can make out from the plots. Right, now we move ahead to actually figure out if there is something useful over there. So now I want to see how my price is distributed. So I use SNS or distribution plot, dist plot. I'll pass the column. It's a distribution plot. It will plot histograms and give me a KDE plot or a curve. So how my data is distributed if I want to approximate with a normal curve kind of a thing. Okay. So I can see that my data is pretty normally distributed. It is averaged around 135, 1035 dollar oh sorry 5 10, yeah, so it's around 12 to 13 million dollars is the house price. It's pretty much, yeah. And on the both the sides of this average, they are fairly symmetrical, so there is no abrupt heights here or there, so it's kind of normally distributed. So let's just to understand this picture in a better way, let's try to plot correlation of each data column with the other data column, right? So we'll use a heat map and we will plot the correlation. So the housing data frame dot corr will give me correlation. These number, you can say that the values of correlation between 0 and 1, and the heat map will plot these on a color scale. So I can see the darker the color, the lesser the correlation. So I cannot see. So see this all this black region, I see there is no relationship between each other, but all these colorful region there is going to be some relationship, right? So I see that price is kind of related with almost all these other columns. So there is no point of studying number of bedrooms versus age of the house. So there is no meaningful relationship that I can figure out because there is no correlation mathematically. And logically also, like a number of bedrooms have nothing to do with area, sorry, house age, right? So I don't know. So if you have more number of rooms, then your house was built 10 years later or 10 years before, you cannot say like that, no. So how, so whenever what is the house of the age has nothing to do with the number of houses in the number of rooms in the house, like that. Okay. So now what I want to do is I want to use all this data, all these 5,000 data points, and I want to use it to calculate a line which best explains these data points, this distribution, or which is the closest to all of these data points, right? So what I want to study is my x should be, so I want to study what is y is equal to just the price column. So y is equal to the price of the column, x is equal to all of these columns, or I can just take any one, right? So or I can take all of them. So I figure out kind of a regression. So how my price is depending on these parameters, you tell me. So I store them in the same way, because I have to figure out the line equation of the line y is equal to mx plus c. So generally I will store my dependent variable, or the y, which is my target variable, should be stored as a small y, and x will be a capital X, because it is going to be a collection of features. So we rarely just study only one parameter, effect of one parameter, right? We can actually do later on, but initially it's okay. We can study the relationship of price with multiple parameters together. Okay, multi-dimensional linear regression, multiple linear regression. Right now we has, because it is going to be a supervised machine learning algorithm. We have 5,000 examples, we have 5,000 houses, all these features I have for 5,000 houses, and I have the price. So I will tell my model, okay, you learn from this, you learn from this data, and I will test your performance on the real world. Now in learning, what my model has to learn, it has to figure out what is the value of m and c, what is the value of b0 and b1. Okay, he has to just figure out that straight line which best explains this data. Okay, nothing else. So I will follow that procedure. We have to divide my data into testing and training, right? So either I can do it myself by using pandas from this row to that row, you take as testing or training, but there is a better way of doing it, is by using Python open source library called scikit-learn, right? So sklearn is this library, maybe I'll, yeah, so I'll show it once, right? So this is the machine learning Python library. Okay, so we are doing regression. You can just go through this website, right? So out of the least curve, if you want to study, right, you can get how to perform. right? If you were to perform this operation yourself only, you have our function, right? We are doing linear regression, right? So I have, so linear regression fits a linear model with coefficients weight to minimize the residual sum of squares between observed targets in the data set and the targets predicted by the linear approximation. Okay, so basically this library is already provided for all of us. We'll be using this model from sklearn library. We'll import this particular module to work for our data set, right? So yeah, coming back from here, I from sklearn, so I could have imported the complete library, but so huge, I don't want to unnecessary make my program bulky, right? So I will just I want to, so there is a functionality called train test split by default defined in this sklearn library. So I will just import that. So sklearn from model selection, from model selection module, I will import train test split. Okay, now, so what this train test split will do, it will take my x and y values, and it will take a test size. So test size means 40% and 60% division I'm doing. So 40% it will take it as for testing, and 60% goes for training. And random state is just to get the same results as me. So you can do not use it, but or you can use the same number, any number you can put, just to initialize this randomization of selection, right? So what this will give me is that I want to divide my data into train and test. So I will have x train and y train. I will have x test and y test by using this just single one line. So it will basically divide my whole data set into two parts, testing and training. And for both the parts, it will have x train and y train, x test and y test. Okay, so y is our price. So it will have all the features, and what is the price, all the features, and what is the price for both of the two divisions. Okay, now once I have divided my data, now I want to create a machine learning model, right? So I want to create that equation, line of equation y is equal to mx plus c. So for that I could have defined my own variable, okay, some random, okay, this is the slope, this is the intercept, something. But all the math has already been implemented and very well tested and available for all of us to use, right? So from sklearn linear model, I'll import linear regression, right? And now this linear regression functionality has been imported in our program. To use it, I want to instantiate it, or I want to create an object which can use it. Okay, so it's like you can hit a six, but you need a bat and actual ball to hit a six, something like that. So to actualize this thing in your code, you have to create an instance of linear regression. Now I have a linear lm variable, which is a linear regression model. I will do lm dot fit on x train and y train. So this is my process of my machine learning. So this is who, this line is the complete machine learning programming in this code. Okay, this, so when I do linear regression, this model learn from x train and y train, right? You learn it, now you give me the results, right? So now it has learned, see, it has given, so copy x true, fit insert true, everything, it has learned something. Now I want to see, give me the intercept. So what is the intercept means, b naught, or the constant part, c, right? So intercept is this one, and coefficient is this one, right? So coefficient I have for each x1 x2 x3, I had multiple 4 5 parameters, so I will have 4 5 coefficients. So let me just again how can I, where do I get the option? Oh, not, yeah, okay, yeah, correct. So here if this was my equation, y is equal to, this was my equation, this is, so my, this is m, and this thing is c, right? My equation is y is equal to mx plus c. Here x is, if I take just one variable, then it is fine, otherwise it can have a collection of variables. So what it is saying is that intercept is this one. So first of all, this thing is negative, that means my line looks like, and what is my coefficient is positive, yeah. So for, if I plot this, so my line looks something like this. So it is, my coefficient is negative minus 26 something something is there, this is negative. And my slope is what, it says 2.15, that means 10 theta is 2.15, so somewhat it's like this. So basically the line is going something like this, right? This is the slope, and this is my x and y axis. So basically, so this thing gives the slopes with x1, this thing gives the slopes with the other thing. This is the slope with the third parameter, fourth parameter, and this fifth parameter, right? So for if I plot linear regression with all the parameters, I will get m the values of m and c, m1, m2, c1, c2, m3, c3, right? So here this m is going to remain same, right? So if you want to plot, let me just remove erase. Okay, now this is what my model has learned. These are the parameters that I wanted it to learn, and it has learned from those 5,000 data points. Now see, I want to just to print it in a better way. I am creating a new data frame which is called coefficient df, and it is a pd.data frame. I am entering all the coefficients. So this is lm.coef, and I am getting this output from my model which I fitted over this x train and y train. Right now, next I am plotting this with x dot columns. So the columns, and I'm naming my columns as coefficient. So I want, this is my coefficient, and I want to name my columns as this, and my row names are going to be x dot columns indexes, right? So just to print this in a good way, right? So now these are the coefficient corresponding to all these parameters, coefficient with respect to price. Now what do they mean? So holding all other values fixed, 1 unit increase in income, area income, is associated with an increase of $21.25. So basically, if the area income increases even by $1, so my price of the house goes by $20. Okay, and if the house age is increases by 1, then my price goes up by around 16,000. Oh sorry, it was 1,64,000 or 1 million, 1.6 million. Okay, million is 10 lakh. No, it's not million, it's 1,064 164,000 if you want to call it in the US convention, right? Or 1,64,000. If the number of rooms, if you increase, so if you are looking for a house, a 2 BHK, and if you go from 2 BHK to 3 BHK, the price will increase by 1,22,000 rupees. This is what my model has done, and it's kind of correct only if you are buying a house, right? So now if number of bedrooms increase, so if you have two, I think, so if one bedroom increases is to 3, from 2 to 3, the price is increased by 2,000 to $200, right? But I think this kind of anomaly, because if you increase one room, then the price is going up by 1,22,000, and if you increase just one bedroom, then the price is going by so less. So I'll just take bedroom extra, not a room. So maybe because its data is not perfect. Yeah. So if you increase the population by one person, the price goes by $15. So if you want to just put the concept of this migration into a perspective, then if see every day 100 people are coming to your area for finding, coming to your city for finding kind of a job or anything, it is increasing the price of the house by 150 rupees every day. So if there are 100 people, then the price is 1,500 increase in one day. So that's how you can relate one way. Okay, so next is you can actually take a look at this data set on, I guess, going to be Kaggle. Control tab. Okay, so actually this is the data set. So sklearn library also has some inbuilt data sets, so you can try out with sklearn.datasets load Boston. So it will load this Boston data set, which has 506 rows only, data points only, just for practice. Okay, now my model has learned something, and I got some insight about my relationship of the prices of the house in my area. Now how can I make a prediction? I want him to, okay, if I'm looking for this and this house with 2 BHK house with 3 rooms and this much of area with this much of population, what should be the price, right? So how can I make predictions from one model? This is the whole point. I did this. I tried to put a machine learning algorithm, my linear regression, to predict this house prices. Okay, So to get the predictions, it's very simple. I will be predicting my data on the test data set, right? So I'll create a variable called predictions, and I will do lm linear regression dot predict what is the y value for the x test values, right? This is kind of a test I'm taking from my data. Now I will make a scatter plot of the y test, whatever the predictions come out from here, and what are the actual y values. Y test means the actual values from a data set, and what are the predictions my model made. So it comes out to be like this. I can see that it is pretty good. So what this plot says is just that yeah. So for this, suppose if this is the x is the y test, so the actual value of the house is this one. My model is saying something around this much only. The actual price is this much. My model is saying something this much only, because there is so much of overlap. I'm not able to actually locate my point. So basically, if I take this point, then the actual house is price is around 130, and my model says it's around what? It's around 1000. So there is a difference of 30,000 or something. Okay, so it's some kind of close but not good. And let's see. Okay, so next let's try to plot uh, the distribution of error for all the data points, right? So for all the test values, I want to find what is the distribution, or what is the distribution of errors. So I am for all the test data set, you take the y value minus the predictions and you give me a distribution plot. So this is what my distribution looks like. So basically for most of the values, my error is almost zero, right? From this graph also I see the same thing, right? For most of the values it is kind of written the same thing. So think of an example where you're taking a house somewhere here. Oh, sorry, let me take a house somewhere here, right? So its actual house price is 1000 and its predicted price is also 1000. Think about all the houses over here. So there is a very good prediction which is being made, right? They are kind of same, right? So this range and this range are all same. The scale is from 0 to 200. There here also 0 to 200, right? So it's difficult to annotate in this Zoom. Okay, so this is the plot of my error. So for I see that for maximum houses, the error is almost this much, zero, very less, very less, right? And as I go away, I get some houses have errors, of course, just like we saw this particular example where we got an error of $30,000. Okay, now let's look at whatever the what are the regression.
1 minute, sir. I think.
Yes.
I think Shashidhar has left the meeting.
Okay.
Yeah, that's the. And one more thing, sir. Apart from that, you call this error, which is there.
Yes.
Yeah. So, what type of error it is? It is mean square, like
It is
we mentioned
mean
regarding
absolute. Yes, correct.
Yeah.
It is MAE currently, because we are just taking the difference here right now. So it is a mean absolute. Yes, correct.
We are not squaring it, and it is absolute error. Yeah.
Yes. Actually, it is not absolute error. It is just because we are getting the error in minus also, right? We are plotting the error, and I have negative error also. So it's basically just because there is no absolute. When we are not use this. So we are just taking whatever my test, whatever is the actual value minus my predictions, right? So it can be negative and positive both. It is just the difference of these two values. So this is
okay.
So I can use absolute value also, but it will, because see it is my origin. So origin is not here. The origin is here. Here is my origin. So I'm getting negative values also, and it is kind of symmetrically distributed. So now we will look at regression. What are the matrices we can use? So one is mean absolute error. I can just average the absolute error of each data point and take a summation of that, right? Or I can find the mean, take the square and then average it, or I can take the root of the squared error and take the mean, right? So all these I can do manually. I can use numpy also, just like this. I plotted, like this is a manual calculation that we are doing, but we have by default a functionality defined to perform all these functions, right? So MAE is the easiest to understand because it's the average error. MSE is more popular than MAE because MSE punishes the larger errors. We have seen in the presentation, right? So because we are squaring the error, so any any error which is huge becomes more bigger number when we square it, and it easily comes into the notice. okay, which tends to be useful in the real world. And RMSE is even more popular because RMSE is interpretable in the Y unit. So basically, mean squared error will give me dollar square. The price of the how the error in the prediction is 500,000 square dollars, right? But when I root it, it's easier to understand. Okay, for predicting the prices, the error is $15,000, right? We can relate it. So all of you, if all of you make your own models, then maybe we can compare whose model is best, and yeah, how, why. Okay, so we can directly just import from sklearn these matrices, all of these, and I can use it to print my result to get. Okay, so what can I do is I will import from sklearn import matrices, and I can print MSE matrices dot MAE, mean absolute error, on y test and prediction. So I'm just providing it the values and asking it to give me the mean absolute error, provided the values and give me the mean squared error, right? And the squared and the RMSE is will be np dot square root of the mean squared error, right? Matrices dot. So it the all these errors come as a method defined inside the metrics functionality from the sklearn library, right? So I can print my result like this. So in this particular model, my mean absolute error is around $82,000, right? Mean squared error is so huge, but this is what I will use. So here my RMSE is around $10,000, and I think it is fine. It is not 10,000, it is $100,000. It is 1 lakh. So basically, if we are talking about in Indian context, then the model is predicting the price of the houses, and the error is around 1 lakh rupees. Okay, which we can say a good or bad, but when it so when, if it is predicting really good for houses, like the house actual price is what 65 lakh, but my model is saying 66 lakh, so I think it is fine. We can make, because actually we have spent only what around 10 to 20 minutes in making this model, so we can spend some more time to collect more data to improve my result better, right? Just for this example, I'm getting this much of accuracy, right? So this is what how we approach to solve a problem with machine learning accuracy. So this is a complete project where we finally report our error, and we see that we are making some insights that the error is quite good based on the context, right? And later on we'll see how can I we'll see one more case study in linear regression, and we will see how can I use other machine learning techniques to even further improve my model. Okay, so generally the trend looks like this. We will be having a working with some data which is coming to us in the form of a CSV file. We'll read the CSV file. We'll get a look at all the columns. What is the how my column looks like, the basic statistics of the column, right? Then we will plot all the features with each other and try to see if there is any trend over there. Then I always try to figure out and take a look at my target column. How is it distributed? Are there any discrepancies in the data, or do we need to perform some data cleaning? So we will in the later lectures look at how can we perform data processing, right? We also try to confirm our assumptions that we made from this EDA by plotting a heat map of the correlation of the columns, right? Then we can use a machine learning model, right? So to use a machine learning model, I need to prepare my data in the form of this X and Y's, and I need to import test and train split method from the sklearn methodology. I will divide my data into X train and X test, Y train and Y test, right? And then I will use the machine learning model to train or learn from my particular data example. So I'll import the model I want to use, in this case linear regression. I'll instantiate my model, create an instance of my model, then I will train this model, or say fit is the word, model dot fit on X train and Y train. I will check the results of my model, that in this particular case it is the intercept or the coefficient. I will try to make sense from the result. If I'm satisfied, okay, these outcome is good for me, then I can go ahead with the predictions. Once I will try to plot my predictions with the actual values, and if it is good enough, then I can try to see what is the general error. And to plot or understand about the different errors, I can use these three evaluation matrices that comes with sklearn library, right? I can import it from sklearn. I can use this method metric dot mean absolute error, provide my y test and predictions, right? or if I want a square error, I can do y-test and predictions, and I can take the square root using the numpy library. Okay, so that's it for today and from my side with respect to linear regression. Okay, I'll give you an exercise as an homework, which should be, yeah, this is your, and we can look at one more. I can, if you do this try to do this problem, right? Let's see how far can you go through. So this the exercise is in the same format. You will have certain questions. You just keep answering the questions, keep writing. So just add an extra cell before it, right? So that you do not lose this output to check whatever your output is. So to get this output, what will you do? You will do describe method. How will you get this output, right? Now you have to make some plot based on Seaborn. This plot you have seen before, you go back, what plot is this, you try to plot it, right, and try to figure out what is there any sense. So I can say that there is some fishy thing going over here, and some fishy thing might be going over here too, where you can use actually a linear regression to solve it, right? Then you will be plotting those two parameters. You get a hint from here, length of membership, yearly amount spent, and you can maybe then try to split your data in before splitting, just define your x variable and the y variable, right? Maybe use model selection, test and train to split your data, then train your model and create an instance of your model. Everything is just keep following the instructions and you get the output like this. You may get some different output based on the particular randomization that happens, because from the lot the division is of 80% train and test division is happening randomly. Okay, so it is not like top 80% goes to testing and training, and the last 20% goes to training. It's not like that. Okay, so then you will make some predictions. You will try to plot predictions with the actual values, and then you will evaluate your model using your error matrices, right? And your error can be different from this one. Okay, now we will plot residuals. Residuals is just y, the same thing. The y at test minus the predictions and a histogram of that, right? You can now maybe try to reduce something that uh, that you can make out from your analysis, right? Okay, so guys, thanks a lot for your time. If you have any doubts, you can ask now. Otherwise, we will see you in the next class.
Yeah, once we will work out, sir. I think once we start practicing only, we'll be getting doubts.